Okay, in this video, we're going to go through the first section of Chapter 2. It's called Reasoning and Proof, and we're going to talk about inductive reasoning. So let's start right here. Okay, so starting with vocab, a conjecture is an unproven, so let me get my pen going here. This is unproven statement that's based on observation. Okay, inductive reasoning is used when you find a pattern in a specific case. And a counterexample is a specific case for which the conjecture, so the unproven observation, is false. So for example, if my conjecture was every Monday it rains, because I see this pattern, and I want a counterexample about that, my counterexample would be this Monday it did not rain. So that counterexample made that conjecture incorrect. Okay, so then let's keep going. Okay, describing a visual pattern. Describe how to sketch the fourth figure in the pattern. So what am I seeing? I'm seeing I have one line dividing that circle in half, and I colored in the top, or I colored in half of it. Then I put two lines, and I colored in one of the two lines, a quarter of the circle. So here I've colored in a half, here I've colored in a quarter, and then continuing, I'm going to put 1, 2, 3 lines and color in one section. So I have 3 lines and I've colored in one section. In this case, it's 1/6. So what's going to come next? Well, I think I could make a circle, and instead of having 3 lines, why don't I have 4 lines? There's 1, there's 2, there's 3, and there's 4. So if I had 4 lines and I colored in one little piece, that would be the next figure in the pattern. So I just observed a pattern. This would be inductive reasoning. Okay, example 2. Describe the pattern in the numbers. Okay, -2, -4, -8. So here I said times 2, here I said times 2. And if we're going to write the next 3, I would take the -8 times 2 and get a -16, the -16 times 2, -32, and the -32 times 2, -64. Again, also inductive reasoning. Okay, this says make a conjecture. So conjecture is an unproven statement that is based on an observation. Okay, given 5 collinear points, make a conjecture about the number of ways to connect different pairs of points. Interesting. Okay, I can connect, if I made these numbers 1, 2, 3, 4, 5. So using my blue first, I can connect 1 to 2, 1 to 3, 1 to 4, 1 to 5. Okay, so that's one way to do it. How many lines did I get? 1, 2, 3, 4. I got 4 lines. Okay, how else can I? So pretty much 1's connected to everything, right? Let's go with 2. 2's already connected to 1. So how about 2 with 3? Go back to 2. 2 with 4. Go back to 2. 2 with 5. Okay, that's another 3 ways. So now 1 and 2 are connected to everything. Okay, what could come next? How about 3 with 4 and 3 with 5? That's 2 more events. Now 3 is connected to anything, to everything. And lastly, if I connect 4 with 5, every single one is connected with every single one other. So this is 4, 7, 8, 9, 10. So there's 10 connections if I have 5 dots. Okay, so that's interesting. So that was a visual pattern. Let's keep going. Make and test a conjecture. Numbers such as 3, 4, and 5 are called consecutive integers. That means in a row. Make and test a conjecture about the sum of any 3 consecutive integers. Okay, let's start looking for a pattern. How about 1, 2, and 3? If you add them together, you will get 3, 4, 5, 6. How about 2, 3, and 4? That's 5, 6, 7, 8, 9. How about we'll do the 3, 4, and 5. That's 9, 10, 11, 12. Okay, do we see any patterns yet? Is there any way we can figure this out? Let's go for one more. How about 4, 5, and 6? That's 9, and 6 is 15. Well, I'm looking and I'm saying, oh, I have patterns that all my answers are multiples of 3. Let's look here. Look at this middle number. If you took the middle number and you multiplied it times 3 terms, wouldn't you get your answer? So 2 times 3 is 6, 3 times 3 is 9, 4 times 3 is 12, and 5 times 3 is 15. So I'm going to say, this is my conjecture right here. Multiply the middle number, take the middle number times 3, and you get your sum. That's a fancy way of saying sum. Okay, that's my conjecture. Okay, finding a counterexample. So let's think about this. A student makes the following conjecture about the sum of 2 numbers. Find a counterexample to disprove the student's conjecture. So conjecture is like an educated guess based on a pattern. Okay, the sum of 2 numbers is always greater than the larger number. Okay, 2 plus 3 is 5. Okay, that sum is greater than the 3. So yes, that's true. How about 5 plus 6? That's 11. That's also greater. So I'm thinking I have to have another way to do this. They didn't tell me how the numbers are related. They didn't tell me to always pick positive numbers. What if I picked a -4 plus a 2? That's going to give me a -2. Is that -2 greater than the larger number? So this is no. So this is your counter example. Okay? Okay, now this is the last thing we're going to do. What conjecture, so educated guess based on observations, could a high school athletic director make based on the graph at the right? So look at the graph. Here are your years. So that's 2004. So 1995, 6, 7, 8, 9, 10. They go by 1. So this is 2005, 6, 7, 8. This only goes up to 2008. Okay? This is girls, and this is girls' registration in thousands. So understand what the graph is telling you. Is it true that so which conjecture could a high school athletic director make based on this graph? More boys play soccer than girls. Nope, it tells me nothing about boys, so I can't make a conjecture about the relative numbers of boys and girls playing soccer. More girls are playing soccer today than in 2001. So possibly, right, because it looks like it's going up. So if it continues to go up, so this is a possibility. Let's read another one. More people are playing soccer today than in the past because the 2000 World Cup games were held in the United States. There's nothing here that refers to that, so I would say I can't use that. The number of girls playing soccer was more in 2001 than in 2007. Nope. So this is my best conjecture right here. I see a pattern. The pattern appears to be going up, so I'm going to conjecture. I'm going to have an educated guess based on this pattern that will continue, and that would be B. Okay? So that's it for the notes. So make sure you copy this down. Now you're going to look at the homework. So see if you can get another figure, or describe how to sketch the fourth figure. Describe the pattern in these numbers and write the next two numbers. Give the pattern of triangles below and make a conjecture about the number of segments in a similar diagram with 5 triangles. Numbers such as 3, 11, 15, and 29 are odd numbers. Make and test a conjecture about the product of any 2 odd numbers. So look at some patterns, see if you can make and test the conjecture. Find a counterexample to disprove the conjecture. Supplementary angles are always adjacent. Okay, so think about that from the last chapter. And which conjecture could you make based on the graph? Okay, read everything, look at the graph, and answer that. Okay? Okay, thank you for listening.